There we go. All right. Today, we're going to begin talking about what?
Did you look here or there? Hey, look at that. They say the same thing though. Okay, here's the thing. First and foremost, we got to talk about the difference between weathering and erosion. Erosion is the movement of weathered material from one place to another. If you are doing your chapter vocab, you've probably reached this term by this point.
Yeah.
I haven't reached it.
Wait, you don't have to move because when it weathers, it gets small.
We gonna pay attention or we're gonna chat? Okay. So here's the thing. A lot of times people tend to think about weathering and erosion being the same thing, but they are not.
But they're very closely related.
Weathering is when the rock breaks or changes substance. Erosion is simply the movement of it. Make sure you know the difference between those two terms, or this test is going to kick your tail. Okay? Make sure you know the difference. Weathering leads to sediment. This is your first blank. Weathering produces sediment. And when you take sediment plus humus, what's humus again? Decomposing animal and plant matter. Yes, thank you, Emma. Humus is just that stuff.
Sedimentary rock.
Air and water. Then you form soil. So weathering breaks down the rock to form sediment. You take the sediment plus humus, all that decaying plant and animal matter, air and water, and you get soil. Remember we talked about soil yesterday. What is soil?
Humus, air, and water.
And what is sediment? Broken up rocks and minerals. Hey, look at that. We're cycling back to previous terms.
You could just crack a rock into small pieces.
Theoretically, yes, you could. You have to get humus.
You could literally find your dog's. If you have a dog, your dog's poop. Use the poop of the dog.
What's it have to? Wait, that's included. Yes. All right. So, yes.
Just because I have to ask, what is your shirt?
It has to do with English class. It says read banned books. We talk about book banning in English class this week, and that's why I have it on. So we already talked about this. When weathered material moves from one location to another, that is erosion. And those two often work together. Weathering and erosion often work together. They are not the same thing. I already discussed this. Weathering breaks down the rocks. Erosion does what? Moves it. Wow, already? Wow, look at you go, girl. Yeah, I never figured it out this summer. Yay! So I just got to go figure out. Yeah. The devices and just that's all it's bad. It's so much better than installing it on to an individual. That's awesome. I have a feeling that once you do that and we can get that done, the middle school teachers will probably be like showering you with treats. Thank you. Big. In case you're wondering, I asked her last year that the curriculum we use has a program that lets us create our own tests, but it also lets you take the test on a computer, which automatically grades it.
Instant brain.
Time time.
Oh yeah. Happy belated birthday because I did see.
Yeah. If you leave the screen, you failed it.
You're not gonna have 2 computers.
Not enough.
Silly goose.
No, it would still be in here on the test.
No, they'll still have to. They'll go back and add
Their
something again.
people. Yeah, that's fine. All right. Had to wipe everything. All right, back to the lesson. We are talking about agents of erosion today, and what that means is the forces, the things that erode the weathered material. The first one that we are going to talk about is gravity. It is the primary force of erosion. What does that mean?
The biggest one.
The biggest one, the number one.
That kind of makes a lot of sense.
Now there are additional factors: water, wind, and ice.
I get
Yes.
water.
We're going to talk about ice. Just wait. Water, wind, ice, and gravity all factor into erosion, but the primary one is gravity. Some of you are listening.
Gravity. Hey, I just thought of something.
Gravity. Gravity. That's what you were doing.
Gravity.
Now, the visible layers of rock. You know when you're driving down the road and they've blown out the hill so that the road can stay level. What do you see in the rock? Layers, okay? Those layers are caused by a process called deposition. What was your question? Sherry, what was your question? You said something. You said something, just kidding. What did you say, Timber? Yes. You can usually see those too. Yes, that's gravity. Okay. The process, we are not testing gravity right now. The process by which those layers of rock are laid down, it's called deposition. Do you hear the word deposit?
It was in the
Okay.
chapter 5.
Look at that too. The heaviest sediment drops first. That creates the first layer that you see. The next heaviest drops second. Okay. So let's talk about gravity and how it moves rock. First one we're going to talk about is called soil creep. No, we're not talking about a creepy sus person. We're talking about creeping along. What does that mean? Barely slowly, yes. So it happens slowly down a hill because what's the primary force? Gravity slowly pulling it down the hill. It is not deep. This erosion happens surface level only.
Oh, did you show us a picture?
What's it moving? Gravity down the hill because of gravity.
So imagine.
The second is called earth flow. Now, obviously, do soil creep and earth flow sound like the same thing? No. What would you expect from earth flow? It goes faster. Okay, on flow, this is going to happen on the sides of hills and mountains. Pieces of rock tumble down much faster.
It's like an avalanche.
They dislodge other rocks and sediment, and it creates a domino effect.
There's so.
Huh? Yes, exactly. How many of you like to set up dominoes just to knock them down?
Me.
Okay. Picture that, but with a rock. The rock that starts at the highest point knocks others down until you have a whole bunch of them coming down. And you're going to be able to see proof of this as a pile of rocks and soil at the bottom of that hill. Now, I will say the Department of Transportation has messed up my examples. You know the road between here and Pawhuska? Okay. There's a new road now, and there's one being built. And so a lot of my examples have disappeared. You used to be able to see that on the way there. You'd be able to see those dislodged rocks piled at the bottom. And this can happen quickly or slowly, technically. Usually it's going to be a quicker thing, but sometimes if one rock starts tumbling down, it might only be a couple of smaller ones. It's when those big rocks fall that it's a problem for whatever's below it. Again, this is also surface level only. It is not deep. See that one?
So it's like an avalanche, but like less serious.
Yes.
What if there's an avalanche in a cave?
That's typically called a cave-in. That's just when the rock falls.
And
Yes.
What exactly does not see?
It means it, well, keep in mind, we talked about several different levels of soil. We're talking like just the first couple layers here. It might affect the topsoil, but it's not really gonna go deeper than that.
Wait, so this is basically the same thing that happens with snow, as in like a snow avalanche?
Yes, it's the same process, yeah. It's just much less dramatic. Now you have pictures of these happen, or you have pictures of these in your notes. I didn't put them up here on the slide because it took up too much space. They are in order. So you see those first two pictures on the front? What's the top one? Soil creep. What's the second one?
That looks really like earth flow.
Earth flow. Okay, make sure you
You can
understand that
barely
these are in
soil.
order.
Soil.
Yep,
Like anything. Looks like nothing.
exactly. Happens very slowly.
Slow, gradual.
The next one is called mud flow. We are increasing a little bit in
Danger.
yes, danger. Obviously, to have mud, what do you have to add in?
Water.
Water.
Well, water
Okay.
is part of soil. So just
But
add
more water to make it actually
it's
mud
basically just like water. It's like basically just like soil creep.
and a lot faster. Because here's the thing, mud flow, because mud has more of a liquidy texture to it, it can flow more like water. So it moves a lot faster than these little individual particles of soil. And because of that, it moves so fast that it can quickly devastate whatever's underneath it. Have you guys, oh, you probably don't watch the news. I should find clips of these.
I don't want.
But mudslides have been an issue in recent years, especially out on the western coast where there have been a lot of forest fires. Because if you take away the vegetation, what's going to happen?
A lot of stuff is gonna go down.
A lot of stuff moves. Plants keep soil in place. When the plants die in a forest fire, and then it suddenly rains, all of that goes flowing down, and so it becomes a problem.
Is mud flow basically just a mudslide?
Yes, mudslide, yeah. Next we have a rock slide. Notice all of these things are a little bit different in what gets incorporated. This is when a huge slab of rock breaks off. Again, you used to be able to see this on the way to
I can see
Huska.
a different rock.
No.
That would be.
Like I said, my example got messed up because they're no longer there. But you used to be able to see, like, we're talking table size slabs of rock at the bottom of the hill that had fallen down. By the way, do you know why they're rebuilding that road?
Because of that.
Partly,
As a rock slide.
a lot of it is not just what's above the road, but
What's below it?
below. There was a time when literally a huge chunk out of one lane, like literally one whole lane, disappeared because of a landslide. That's something that you want to drive your car into.
Yeah.
Yes, Timber.
Look there. Sitting.
Yeah, because shoulders make it paper. Lastly, we have an avalanche.
Spell this one.
Well, everybody can spell this one because it's right there.
Yeah, but I know it by memory.
What in the world?
Oh.
Oh. There we go. Technically, by definition, an avalanche is a mass of snow on a mountainside that becomes unstable and goes flying down. You've all seen the movies. This is like a big dramatic moment in any movie that is set anywhere that has snow. They like to do avalanches because it's very dramatic.
Yeah, because it kind of like gets really big.
Yeah.
Because
How
it
could
like
an
ends
avalanche
down
kill
to
you?
like force because it's cold and you get trapped under and you can't move and
Yep.
you can't breathe.
like
No.
cliff or whatever. And they had like these like little nets that would keep the rocks from like coming off.
Yeah. I've seen those around here too. Because when there's not a plant life, you got to do something to make sure it doesn't fall.
There's an avalanche of water.
Anyway, that's not an
That's
outlet.
animated.
Now we're going to look specifically at stream erosion next. Stream erosion means it's happening with what? Water. Now, obviously, when I say stream, I am basically meaning moving water. River, creek, tributary, stream.
Literally
It's
anyone.
A smaller flowing thing of water that flows into the bigger one. Those are all the same thing. It's literally just size. First thing you need to know is the term load. Load, yes, that's in your vocab. Load is the sediment that a stream carries. Makes sense, right? What's a load that you carry every day?
My backpack. This
Super quick and a little bit testy with that answer.
here. This
Okay.
thing is what keeps
Now,
me alive or something.
You have dissolved load. You should be able to figure this out based by the title. This is when the minerals are actually dissolved in the water. You cannot simply look at it and reach your hand in and strain out the minerals. They're dissolved in the water, much like if you have a saltwater pool or even chlorine, whatever. It dissolves into the water. Now, let's talk about the Dead Sea for a minute. Anyone know where the Dead Sea is?
Israel.
It is over in Israel. Exactly. Why is it called the Dead Sea?
Nothing can survive because it's so salty, and you can
Yeah.
float in it without trying.
Okay.
You cannot sink.
So I'll show you why. I don't have a picture. But basically, what happens is this little river flows into the Dead Sea.
Isn't the Dead Sea like super clear?
No, actually. The river that flows into the Dead Sea. Do you notice what's missing in that drawing?
No output.
There's no outlet. Okay. Anytime you have flowing water, it's going to carry things with it, whatever it comes into contact with. So one of the most common minerals in soil is salt. There are various types of salts, by the way. So this river flows into the Dead Sea and it has nowhere else to go. Well, you learned this in elementary. What happens in the water cycle with a body of water? Where does the water go? It evaporates. Does the salt evaporate with it? No. So all of the salt that flows in stays there. The water evaporates. And so that means there's water constantly flowing in, constantly putting in more salt until the point was reached that nothing could live there anymore because the water was too salty for it. Yes.
Oh.
Okay.
Why is it called the Dead Sea? And if you can't
Nothing
really
can
die
live. No, it's the fact that nothing can live in it. There are no fish. There are no fish in the Dead Sea. Yes.
You
In
eat the
places, yes, and I feel so bad because I feel like the sixth graders, I always tell you next year or eighth grade. In eighth grade, you will study the Dead Sea more in depth. And there's actually pictures in that slideshow that show you that, yeah, you can literally see the salt deposits around the rim.
Oh yeah, I see it.
It changes eighth grade. It changes the density of the water as opposed to the density of you. And so it makes the water more dense than what the water in your body is, so you float. But the Dead Sea is an example of a dissolved load. The salt is dissolved in the water.
What if you swallow some of the Dead Sea water?
It would be super salty. The salt is dissolved in the water. The only way to separate those two is to have the water evaporate. There's also what is called a suspended load. What does suspend mean?
Probably like not
Like,
in the
make it
water
long.
fully.
Not really in the water. Kind of think of sort of like a floating.
It just
Like a
comes
bungee
along
jumper,
suspended.
like Yes, a bungee jumper suspends above the ground.
Oh, I would hate that.
So in this one, sediment is carried along by the water, but it does not dissolve.
That would be kind of cool. Just
Hi.
You guys write that down? Now, suspended loads have an added thing to them that they are abrasive. What does that mean? We talked about abrasion.
it knocks stuff and it's rocks rubbing against each other.
It is rocks rubbing against each other. So that suspended load contributes to further weathering. Abrasion happens here. Why do I have / erosion?
Because then weathering goes to erosion and no
Moving. We know.
There we go. The abrasion contributes to the weathering, but the water then erodes the further things that have been eroded. And I'm going to give you a PSA right here. What's that mean?
Public safety announcement.
Public safety announcement. Never cross a flooded area. Okay, it's been a few years since we had a flood in this area. But here's the thing. When you have flood waters that are flowing, what did I say that flowing water does? It takes everything it comes into contact with it. Now, yes, if the water's flowing, especially if it's flowing, the current is below the surface, you may not see it. It could take you. But it's also the fact that it takes everything else. That means all the animal poop that it has swept up from the pasture that it flowed through before it reached you. That means all the chemicals in the junkyard that it swept through before it got to you. That means all the trash and debris from wherever it swept through. There are additional bacteria, there are additional chemicals, and then there is stuff that could literally impale you in floodwaters. I cannot tell you the number of times I have seen people posting on social media, playing in the floodwaters, and then lo and behold, a few days later, they're at the hospital because they're sick from something they contracted from that water. Is it fun to play in the water?
Yeah, it's really
It
fun
is.
to play in the water. In clean water.
Then you got lucky.
In clean water.
In clean water, and that's the thing. If you don't know whether or not it's clean,
Don't jump in
Yes.
puddles, kids.
Mm-hmm. Mm-hmm.
So it was like all the way up to the stop sign.
Mm.
Then it was like completely.
Above, yeah. Yeah.
You could use a boat.
But then you're not in the water, so it's okay. Yes.
So how do you? It's not gonna.
That one you are having to trust on the engineers and scientists who tested the water to make sure it's okay to swim in.
And then
If there's a public swimming pool or a public swimming area, you're
and then
lost the second question.
So here
Mhm.
we have to pass through Canyon River,
Mhm.
and that whole field that it was by was flooded.
Yeah, it got pretty bad in some areas. Oh, another thing I didn't say this. If flowing water takes everything with it, why should you not drive over a flooded road?
Because you'll get taken away with it.
That could be it, but why else, Timber?
Well, I have a question.
Yeah.
Wouldn't it be okay even if it was only like 6 inches deep if you drove through it?
That's a little different. If you can see the roadway beneath it, you're probably fine.
And if
The issue is once you get more, especially if you're in a vehicle, like walking through that, I would tell you no.
Yeah.
Because especially if it's flowing quickly, your feet are not strong enough to hold on to the ground. But if you cannot see through the water, the road may not be there. I have seen that happen too, actually. Out on the way to my parents' house, last time we had those huge floods, there was a road that literally it took the entire road bed off. there was literally no access down that road. And you can still see today where they had to build the new road because you can tell the difference in the asphalt. But people didn't pay attention and they decided to go that way. And I saw pictures where the car is literally sitting like this because here's where it landed after the roadbed was washed away. So
So basically what you're saying is don't drive or walk or do anything with this.
Also, don't let your
it's a
pants
whole lot safer if you just go play in some clean water.
and don't let your pants in a flood.
Yeah.
He's gonna
Now there is some water erosion that's beneficial. I know I probably scared you a tiny bit with all my talk of floods, but there is some beneficial water erosion. Because when water floods, especially in floodplains, it can bring a lot of nutrients for the soil. Your body is not necessarily designed for the things it brings, but the plants can use it better than you can. This is exactly what happens along the Nile River. This is why ancient Egypt thrived for as long as it did. Every spring, the Nile would flood. It would deposit all those minerals around the Nile, and then they would be able to use that land to farm crops. You guys have studied ancient Egypt before, right?
No.
But we're probably
Oh.
going to.
I was gonna say, I think you do over here with Mrs. Fingers. Okay, you'll get there soon then. Water erosion can also completely change the landscape. Do you know what a delta is?
Yes. Yes. It's the place. It's the.
No.
It's the place where the ocean and the river meet.
It is the place where the ocean and the river meet. We have the Mississippi Delta here in the US.
Yeah.
And what it does is basically, we talked about this, what does the flowing river carry with it? Minerals, sediments, all of that. The delta is where it deposits it. Well, if you deposit sediment for long enough, what happens? It builds up until it's above the water level, and you are literally adding to the land. Yes.
With the changing landscape, the flood did that.
Oh, yes, because it would talk about lots of flowing water and lots of sediment. Yes. Okay. I have a video for you to watch.
How can this cave be carved out of solid rock? Weathering and erosion work together to get the job done. Welcome to Moo Math and Science and Weathering and Erosion. Weathering breaks the rock down and erosion carries this rock away. Sandy Beach is an example of weathering. Parts of this sand at one time was quartz that was broken apart, traveled down rivers and streams, and ended up as small as a grain of sugar. Weathering of rocks is a physical or chemical change that changes the characteristics of the rocks on Earth. There are two major types: physical weathering, which involves breaking rocks into smaller fragments caused by environmental factors, and chemical weathering, which are changes that involve rocks being changed into new substances or minerals chemically. Let's look at three major types of physical weathering: abrasion, frost wedging, and thermal stress. Abrasion is mechanical scraping and can be caused by several factors. Basically,
Yep, I have a feeling it was supposed to pick up right there.
breaks down the rock. Then erosion carries the rock away. Erosion happens when rocks and sediments are picked up and moved to another place. It can be moved by water, wind, ice, and even gravity. Erosion can occur slowly over time, like this sand dune, or quickly, like this flood. There are several different methods of erosion. Remember, weathering breaks down the rock, then erosion moves the rock away. Rainfall can cause erosion and wash sediment away. Valley erosion occurs when rushing streams and rivers move rock and sediment downstream. A huge force of erosion Wind can cause erosion. A dust storm can be a huge force of erosion. Glaciers and ice can erode rock away. Greenland and Antarctica have huge glaciers that move rock from one area of another. In summary, weathering breaks down the rock and erosion moves this rock away. If you'd like to know more about weathering and erosion, this playlist will help.
Okay, so weathering does what?
Breaks it.
Breaks it. And erosion does what? Moves it, washes it away. So if we talked about gravity and water today, what do you think we're going to talk about tomorrow?
Ice.
Ice and
Wind.
wind. There you go. So we are going to pick that up tomorrow. You do not have homework unless you are not done with your chapter vocab, because we are getting closer and closer to test day. So if you haven't finished your chapter vocab, that's your job for the next 13 minutes. If you have books, STEM bin, puzzles, whatever. Yes.
Here, you can do a table. Because one of